we're going to try and prove the vertical angle theorem. So far today, I've gotten to the point where I only have 4 steps left, and all those classes are just finishing those last 4 steps for homework. I'm giving you the statement, or giving you the reasons, and you'll fill in the statement. We're going to have enough time to actually do it. So we can see that we're given that line AB intersects line CD at point E. That's not point E. Right, that's point B. And I want to prove that angle BED is congruent to angle BEA. Alright, so that's our goal. So we're given that line AB intersects line CD at point. Alright, our goal, like I said, is well, actually, the algorithm of error analysis, where we would show you a proof, and you would highlight where the error is. You can use a proof to show inconsistency, but a theorem is something that so we're trying to run it. Okay, so here's what we have here. What we want to do, anytime that we want to start any 2-column proof, we should always start by saying, over here we have our statement. And then we have our reason. And what is a good way to start any proof? What is a good way to start any Jason? Yeah, same thing given. So we have that line AB intersects line CD at point E. And just like Jason said, that was given. We have line here, a line here, and that was the okay, so from this point on, what we're trying to do is we're trying to present an argument where we prove that angle BED is congruent to angle CEA. So one thing that we can do early on is we need to introduce one of those angles. That's always a good place to start. So let's look at our diagram up here. So here is BED. I'll go ahead, I'll highlight it here. Right, so this right here is BED. And I want to prove this is congruent to this angle over here. Alright, so I want to try and prove those two things are congruent. So, what can you tell me about BED? Just to start with, what do we know about BED and its relationship to another angle that's up here? Thinking about all the words that we've kind of learned in the past, couple of days. Peter, do you have any other relationship that BED has with another angle? We don't know that yet. We got to prove that. That's what we're trying to prove. Rebel, do you have a thought? BED, and what relationship does it have with another angle? Maybe if we all gaze to the right of the board, you guys see that diagram over there. What's going on over there? To the right, to the black. There's a linear pair, BED. Alright? So BED and DEA, so BED right here, and DEA are a linear pair. Alright, so we can go ahead and get that. We can get down that B angle BED and angle DEA are a linear pair. Does anyone want to take a stab at what the reason we're able to state that is? Remember, the reasons aren't hard, they're not tricky, it's actually very straightforward. So how can we say those are a linear pair? How can I say this is a depth? How can I say, what's purple in each rock? A purple rock eater? So how do you know they're linear pairs? It's the definition. Right? Think of the obvious. Try and highlight the obvious. It'll help you very much in this group. The definition of linear pair. Alright, so if BEB and BEA are a linear pair, what else are they? If they're a linear pair, what other kind of angle relationship do they have? No. They are supplementary. Good. So we have angle BEB and angle BEA are supplementary angles. And I know that because of the definition of linear pair. The linear pair is supplementary. Right? And what can you tell me about the measure of BEB and the measure of BEA if they're supplementary angles? So what can you tell me about the measure of BEB and the measure of angle BEA if they're supplementary angles? They equal 180 degrees when you add them together. So we can say that the measure of angle BEB plus the measure of angle BEA equals 180 degrees. All right, if we were able to state that angle BEB and BEA were linear pairs, because of the definition of linear pairs, why can we say that the measure of BEB plus the measure of angle BEA equal 180? The definition of supplementary. That's the definition of supplementary. Okay, so I have now been able to establish a relationship that has BEB in it. And I need BEB, right? BEB is right here. I also need BEA. So let's take a look up here at BEA. You see it's highlighted in green. We are going to do the exact same thing. We're going to use BEA and BEA. We're going to establish the same relationship. So we're going to start with angle BEA and angle BEA are a linear pair. Good. So then if we refer back to what we did the first time, after stating they're a linear pair, we can now state that they are what? After we state they are a linear pair, we can state they're supplementary angles. Good. So we have that angle BEA and angle DEA are supplementary angles. And we're going to use the same reason we use the definition of linear. Okay, if they're supplementary angles, what am I able to say about their measurement? So tacitly, if they're supplementary angles, what can I say about their measurement? Yeah, the measure of angle BEA plus the measure of angle DEA equals 180 degrees. And we can use the same reason definition of supplementary. All right, so I've established two relationships that have these two pieces of information that I want. All right, so what I'm going to do now is I'm going to rewrite this equation. I'm going to rewrite this one right here as 180 degrees equals the measure of angle CEA plus the measure of angle DEA. Which property that we learned allows me to kind of switch what's happening on either side of the equal sign? So what property that I learned allows me to switch what's on either side of the equal sign? Mike, do we have an idea? So if you're having trouble writing down, these are in your algebraic proof notes. Jason? Not quite substitution. So this one says that if A equals B, then B equals A. If A equals B, then B equals A. Was the definition that I gave you. Here, reflexive is if x equals x. So it's going to be the symmetric property. This is the symmetric. I don't even know if we're going to have one. But I think we're going to finish the class in space on the course. All right. So if A equals B and B equals C, then A equals C. All right, if we look up here, we have measure of angle BED plus measure of angle DEA equals 180. And right here we have 180 equals the measure of angle CEA plus the measure of angle DEA. So that allows me to write those two pieces. I can write that the measure of angle BED plus the measure of angle DEA equals the measure of angle CEA plus the measure of angle DEA. What property is it when I have this A equals B and B equals C, then A equals C? We get the transition. You get the transition. So we're close. We got 3 steps. Okay, maybe 4. So what am I trying to do again? I'm trying to prove that BED is congruent to CEA. Well, right here I have BED. Right here I have CEA. I have an equal sign. All right. So what can I do to get rid of the measure of angle DEA on both sides of the equation? I want to get rid of the measure of angle DEA on both sides of the equation. Michael? Subtraction property is long. Great. So I get the measure of angle BED plus the measure of angle DEA minus the measure of angle DEA equals the measure of angle CEA plus the measure of angle DEA minus the measure of angle DEA. And that is by the substitution property of, well, I'll tell you the subtraction property. The subtraction property of. So when I have the positive and negative of the exact same thing, right? So I have plus measure of angle DEA minus measure of angle DEA. All I get is the measure of angle BED plus 0 equals the measure of angle BEA plus 0. And remember what property that is? It allows you to take, it says 2 minus 2 equals 0. Or that's 1,000 minus 1,000 equals 0. Or that's A minus A equals 0. And which one? It's going to be the inverse. It's the inverse property of addition. Alright, last two steps. Measure of angle BED equals measure of angle CEA. What property allows me when I have A plus 0 equals A plus 0 equals A? What property is that when I add 0 to something that stays the same? Identity property condition. Good. Identity property of addition. Alright, so if two measurements of two things are equal, those things are also congruent. What allows me to go from two measurements being equal? Definition of congruence. Hey, we got through it. I think a lot of you need to study up on your properties. They don't go away, unfortunately. Enjoy your week, enjoy your night. You have no homework, we got through everything. That's your proof that we just did. Good job.